rebuild a house with AI. Okay, this is now a very catchy introduction. However, if you stick with me, you will learn that it is true. You will learn why large language models hallucinate, and you will learn what to do against it. So, some days ago, my cousin called me. He is building a house, and he has some offers from crafters how to do it. And basically, these are long texts that have a lot of positions, and in the end, it all ends up in a grand total how much there has to be paid for the house. And now he wants to compare these offers, and for that he has created a table with 500 entries, like what the tiles cost, how big the wall is, what is being discussed to be put into the bathroom, and so on. The heating in the bathroom, everything is detailed in this. And he asked me if AI can help with this. And he already had tried out himself. He had used a famous public large language model, and he had given these offers to the large language model, and the large language model had completely failed in analyzing it. For example, it had said, you're building a garage plus a house, but he was only building a house, and the garage was a pure hallucination. So he asked me, why do large language models hallucinate? And the surprise is that the real counter question is, why do they say something that pleases you? Yeah? Why do they say something right? Because the answer to both questions is the same. And it stems from how large language models are being created. They are being trained. And if you ask experts how they are being trained, they will, how they work, they will talk about something like attention mechanism, and this is all true. However, the point that I'm trying to make is that large language models in the end are based on reinforcement learning. And that is the same learning like your brain works. Yeah? You touch the stove, the hot stove with your hand, and you get burned, and you never do this again. You get punished and you get rewarded. And when you get rewarded, you repeat the action. And when you get punished, you do not repeat the action. And all, it never happens that you do not get punished if you live a complete life, because there are still some uncertainties, still some nuances left that you need to explore. And large language models work exactly the same way. So imagine you are training a model from the ground up. And you're saying like 2 + 2 equals, and the models may answer, I can't answer this. Then it gets punished. So it does not do this again. 2 + 2 equals, the model tries 3, gets punished. Okay, so it will not answer 3 again. 2 + 2 equals, model answers 5, it gets punished. Will not do this again. Model gets asked, what equals 2 + 2? And it answers 4, and it gets rewarded. So this will be repeated again and again. And now this neural network that is being used for many other tasks as well. So with a high probability, it will answer the question 2 + 2 equals with 4. But you cannot exclude that if you train it on a lot of other knowledge, that in that case, somewhen this knowledge will erode, and you will get another answer. And there are many ways how to avoid this. However, in the end, it can always happen with a certain statistical probability that you get a wrong answer, or that you get an answer that the LLM cannot know at all. Where it had better said, I do not know. But it always gets punished when it says, I do not know. Also not as hard as it gets punished when it gives a wrong answer. So the solution, how to avoid, the best solution, in my opinion, how to avoid this kind of hallucinations is to reduce the amount of knowledge so that the LLM will not be as big and have more concise knowledge. So that would, for example, work if you are only doing mathematical questions, only 2 + 2 equals, but that's boring. So we need another way, and we could do specialized models. But then still we have all the world's knowledge, and it will still clutter the whole thing. So the best thing to do is that we, in my opinion, the best thing to do is to use retrieval augmented generation. Retrieval augmented generation basically means you have a text, you give it to the LLM to read, and from then on, all questions will only pertain to this particular knowledge that is in the text. This way, you avoid hallucinations as much as you can sensibly do. And my cousin also used this, and it worked very well for him. Let me show it how I do it. But first, a disclaimer: I work for Google, so what I'm showing here is a Google product, but it has nothing to do with me working for Google. I'm here as a private person doing a private video, and I show this to you because I really find it's a good idea and a good product, not because I'm receiving any money for it. Okay, let's go. I have now created 2 fake offers for building a house. You see here's one, size is 4,000 finished square feet. And here's the other, 3,500 finished square feet. To compare them, I load them into NotebookLM. So I create a new notebook and I upload files, this here and this here, the 2 fake offers. And NotebookLM rags them, so it applies retrieval augmented generation on them. In other words, it is just an LLM reading them and then knowing them by heart. And afterwards, you can ask that thing to summarize it, which it automatically does here. The 2 sources are construction proposals for custom homes intended for the same clients, John and Jane Doe, on the same premium lot. But they present 2 starkly different building strategies and budgets. Okay? So you could now ask what are the significant cost differences between the 2 proposals, and the answer would be that basically everything everything differs. The one is more into being premium, and the other one is more into being economic. And you automatically get an overview. And in case these were real offers, you could now say, okay, it could now say, okay, here. Proposal A is more expensive than proposal B. Also, it delivers the same value. And in this case, you can, of course, go to the offer maker of A and ask him, hey, why are you more expensive? And comparing these offers is absolutely a great thing that you can do with this retrieval augmented generation. As I said, an LLM having read both offers and knowing them by heart, being able to explain them to you, to show up the differences. It would even be possible that you make a podcast or a video over them or a mind map, many other things. But what I want to show you is that this LLM now really concentrates on the text. It is no longer influenced by all the world knowledge of the internet. It really only goes to the text. So if I use some large language model and I ask it, who is Brad Pitt? And it will, of course, tell me it is an actor or something like that. But if I ask it here, the answer will be, this is not in the sources. There's no information in the sources who Brad Pitt is. This, of course, makes it that the model is completely is completely not influenced by this world knowledge and can concentrate only on the offers at hand, which means that it hallucinates less, that it comes to the point, and all these other things. So this is the one use case of NotebookLM, and I did not want to spare you from the other use of NotebookLM, which is IFYA Studies. So I have a little seminar at the University of Cooperative Education, and I have some students there who use NotebookLM. For example, when you write a diploma thesis, you load this diploma thesis into NotebookLM, and then you say, how can I improve it? Or the other way around, you are a student and you get 50 PDFs that you have to learn. And just go into NotebookLM, ask it what's most important. Ask it, to make a quiz out of it, ask it to make flashcards out of it, a mind map, a podcast that you can interrupt with your own voice, or a video overview. So this is, in my opinion, the best way to fight hallucinations of large language models. I hope I could help you a bit. Would be happy to read from you in the comments. See you in the comment section. Bye.